Hi, everybody. Thank you so much for joining us today and welcome to another event from the Microsoft Reactor program. Today we have our speaker, Ted Malone here. He will be speaking about implementing DataOps by using Azure Data Factory and Azure DevOps. And we will get started in just a few moments. Before we get started, however, though, if you have not joined us for a Teams Live event before, there is a live Q&A section. So you should see an icon that has two text boxes. The top text box has a question mark in it. That is the live event Q&A. Throughout the presentation, feel free to ask your questions and we will do our best to answer all of them throughout the event and at the end as well. This event is being recorded and we will be posting it to the Microsoft Reactor YouTube page along with the slides from today's event, and I will share the link for that in the live Q&A as well. Thank you again so much for joining us, and I will pass it over to Ted.
All right, well, thank you so much. I appreciate everybody spending some time with us here today on this particular topic, and hopefully you'll get as much out of listening to this as I did out of preparing to deliver it. So, as Dion said, my name is Ted Malone. I am a cloud solution architect as part of our customer success organization here in the Microsoft West region. Basically, what that means is that I am responsible for making sure that our customers appropriately deploy and consume our cloud data and analytics products. And I am fortunate enough that I get to work with some of our largest customers here in the West region, and I have a particular focus on our hospitality and gaming industry, specifically our customers in Las Vegas. So you can kind of imagine where some of this is going to go in terms of, sort of some of the content and some of the things that we've learned from that. I've got links in the slides. If you download the slides afterwards, you can see my Twitter link. You can see my LinkedIn link. If you have any questions that aren't answered as part of this presentation, please feel free to reach out to me through one of these channels. I'll be more than happy to have a discussion with you if possible for that. So with all of that said, what we're going to do today, I've kind of broken the agenda down over the next hour into these 10 components. Going to talk about DevOps, what is it? We're going to talk about continuous integration and continuous delivery, CI/CD, and why we care about that. We're going to do a brief discussion from a case study perspective of the Mars Orbiter program. If you haven't heard about that, we'll talk a little bit about it and specifically how it applies to what we're talking about here today. Then we're going to talk about some of the elements of appropriate CI/CD practices and then some of the best practices there. Then we're going to shift gears a little bit. Instead of talking about generic CI/CD, we're going to dive into the specifics around DataOps, what DataOps actually means, and specifically Microsoft's tooling in that arena, Data Factory, and then really drill into some CI/CD components of Data Factory, talk about Git integration there, and then kind of close it all up with the CI/CD data best practices, which are going to be slightly different than our generic CI/CD practices there. So having said that and given you kind of the roadmap of what we're going to talk about today, I want to let everybody here know that I am making a rather large assumption about you. And specifically, I'm assuming that based on the title and everything, that most of you that are attending are data analytics folks that have experience working with data, have experience writing ETL, have experience integrating data analytics into your applications, but you don't really have a lot of experience with Azure DevOps as a platform. And that's the big assumption that I'm making. And you're going to kind of see how that goes throughout this, because as we talk about the generic side of DevOps, I'm going to be very high level, not really talking about a lot of the tooling there. But when we get into the data side, I'm going to drill pretty deep into the actual tooling and kind of give you some very specific best practices that kind of come up along the way. So that's sort of the roadmap for what we're doing. So let's go ahead and really jump right into it. So what is DevOps? When we hear this term DevOps, when we think about what exactly DevOps is, the first thing that I want to get across here is that DevOps is not a thing by itself. DevOps is the union of people, of process, and of product. Notice that I didn't say people, process, technology like a lot of terms and things that you see here. People, process, and product that's going to enable continuous delivery of value. I didn't say continuous delivery of software. I said continuous delivery of value to your customers, to your end users. At a very high level, that's exactly what DevOps is and what it's meant to attack in terms of the kind of the problem space. Well, when we think about DevOps and we think about really what makes a good DevOps environment, we have to really think about the taxonomy of what really goes into this whole concept of DevOps. And believe me, when we talk about an hour, and when we talk about the fact that part of that hour is going to be spent relatively deep inside of some of the tooling here, clearly we can't talk about everything that's related to DevOps. And if you think about it from Microsoft's tooling perspective, again, that whole product side of things, Azure DevOps is a pretty wide product in and of itself, and it's really made up of a bunch of different things within that, with Azure as kind of the backbone of it. And then there are some components within the DevOps framework, such as Azure boards, Azure repos, Azure pipelines, Azure test plans, and Azure artifacts. And what these products allow us to do is to build on the pillars that make up a successful DevOps process or a successful DevOps operation, if you will. And those pillars really start off with culture as kind of the main cornerstone, the main pillar of things that we talk about. When I work with my customers, and I'm specifically targeted to work with my customers in the data and AI space, however, it's always part of an enterprise engagement, so enterprise-wide. So we always have to think beyond just the narrow confines of a data and AI operation. And so the big thing that we really work to try to understand and try to really implement is a culture that supports the DevOps methodology. And I'll get into what all of that culture is here in just a minute. But what I wanted to make sure that I got across here is that the cornerstone of all of this really boils down to the culture. If you don't have the right culture, nothing else is going to matter in terms of what I'm talking about. And as we go along, that definition of right culture will really start to kind of shape itself, and you'll kind of see what it is that we're talking about there. Another pillar that we talk about is the concept of a lean product. Kind of in my space as a cloud solution architect, we call this an MVP, or a minimum viable product. Basically what it is we have a customer that says, I want to do X, and what my job is to do is define the minimum thing that we have to deliver in order to ensure that X is accomplished for the customer. And again, we'll talk a little bit about that as we go along. But culture and lean product are really two non-technology sides of the whole DevOps taxonomy. Another pillar that we have is architecture. Now, the architecture is a really important aspect of this, and the idea here is that we've got to be flexible enough to ensure that we can implement the things that we need to implement to drive the right culture, to drive the right lean product, and have the right technology without building a lot of technical debt behind everything. So the architecture becomes a really important part of all of this. As a matter of fact, where I've seen, DevOps initiatives suffer has always been around two things. It's always been around the culture, not really being willing to change, not really wanting to implement the concepts of continuous delivery, and then the architecture, really being focused on driving a very specific, narrow focused architecture that is technology based as opposed to process based for that. So these are some very big concepts here. And of course, the final pillar here, which goes hand in hand with the architecture side, is the technology, making sure that we have the appropriate technologies that can adapt to the things that we need to do. And when you put all of these pillars together, and when you think about the things that they enable, this is really the whole concept of DevOps from end to end. Notice the fact that every single one of these boxes has the word continuous in it, which means that we are constantly planning our product. We're constantly or continuously integrating the product. In other words, my developers are always checking in their changes, making sure the builds go, things like that. We're continuously delivering something. This is very, very important in the cloud world where we're at today. And, I'm an old person. I've been doing this for a long time. And, I can remember the days of, when we have a new version of SQL Server come out, I could learn about that version of SQL Server and it would be good for 3 years. I wouldn't have to really worry about, updating my knowledge or anything else within that 3 years. Maybe every so often we'd get a service pack that would fix a bug, maybe add a new feature, maybe change the way a feature worked or something like that. But generally speaking, I had 3 to 5 years of time where I didn't have to worry about anything changing. As a person that was delivering content to audiences around the world, it was really nice, because what I could do is I could build a demo and I would know that that particular demo would be good for 5 years. I wouldn't have to worry about it. And unfortunately for my audiences in years 4 and 5, they didn't really get a lot of new content, but nevertheless, that demo always worked. Fast forward to today in this continuous integration and continuous delivery world, what I have to do as a presenter is 10 minutes before I go on stage, I have to make sure that my UI hasn't changed. I have to make sure that all the things that I rely on as part of my demo haven't been updated, haven't been changed, or things like that. And that's just a fact of the fast moving environment here, making sure that we can take advantage of that and really understanding how to plan our products to support that kind of a delivery is really important as well. That's where the continuous quality comes into play. And of course, there's nothing about applications today if we don't talk about security. Security is the heart of every single application that exists today. And so security has to be built into the environment here. The ability to support the application, continuous operations, has to be built in. And then being able to collaborate across all your teams, not just once a quarter, once a week, or whatever for the Scrum stand-up meetings, once a day. It's literally continuously collaborating with all of the team members and everything that's going on. And of course, all of this leads to continuous improvement. The idea is that in a quote unquote perfect world, what we're doing is on the left-hand side, we're continuously planning to deliver on the right-hand side that continuous improvement to our customers. And of course, all of that's going to require that we be able to collaborate not only with our internal teams, but with our customers who are using the application or whatever it is that we're trying to deliver. So those pillars hold up all of these approaches for how we're going to do that. And then if we put it into perspective, really what it looks like is, and I know this is really small, I'm going to blow that up in just a second here, But what that really looks like is here are the basics of when we talk about DevOps, here are the capabilities that we're talking about, and here are the practices that lead to all of these continuous quality, continuous operation, continuous collaboration, everything else. Now, clearly, I have an hour of which I've already wasted 15 minutes of, kind of talking about all of these things. So we're not going to be able to talk about each and every one of these bullets here. So what I want to do is I want to focus on two things within these capabilities and within these practices, and that's continuous integration and continuous delivery. I would say to everyone, though, download the slides. I've got a lot of different links and everything in the notes components of the slides here where you can actually drill into all of these other things as well. Hopefully you'll find this very useful in terms of how this all works. But when we think about continuous integration and we think about continuous delivery, these are some of the bullets that I have in these boxes are by no means meant to be a complete story here, but these are some of the things that help us to drive continuous integration. Part of it has to do with how we actually develop. Are we using test-driven development, or are we using behavior-driven development, for example? These are two things that lend themselves very well to continuous integration. And if you're not familiar with the kind of newer concept of behavior-driven development, well, basically what it means is that we continuously plan what the application is going to behave like, or whatever it is that we're building, how it's going to behave, and we develop to that behavior, not necessarily to a bullet list of technical requirements. It's actually a bigger picture of the behavior for all of that. Just like with test-driven development, we sit down, we define how we're going to test what it is that we write the test, and then we write the code. Behavior-driven development is very much the same thing, where we define the behavior that we're going to implement. We figure out how we're going to test that behavior, and then we write the tests and the code to support that. So those are just a couple of ideas there. Within continuous integration, we've got to have some sort of version control. Microsoft's perspective here is that, we purchased GitHub as part of our DevOps environment. Git seems to have become, the de facto standard for version control and source control. So let's just work with that. That's kind of our idea here. So a Git pull request becomes one of the big components of a continuous integration environment. Being able to build pipelines, being able to do credential scanning, being able to do security code scanning, things like this. These are all tenets of continuous integration. And continuous delivery just expands on that and says, well, within our, for example, release pipeline, we have to be able to do things like deploy infrastructure in a secure manner. Things like infrastructure as code is something that's a really big deal in continuous delivery. The ability to create from an Azure perspective, for example, we use ARM templates, the Azure Resource Manager, in order to deploy our infrastructure that support that. That definition of what the infrastructure requirements are should be part of our pipeline and part of the continuous delivery component there. And then there's some other concepts in here around, whether we're going to do blue-green deployment, which is something that Microsoft is really good at. And if you're not familiar with that term, blue-green deployment basically means that you have two versions of an application that are running side by side. The blue environment is the quote unquote new, the enhanced, the improved version, and the green deployment is the one that's been in production running. And what we do is we slowly shift over our user base from the blue deployment to the green deployment in that perspective. And then the green deployment becomes the next blue deployment, if you will. The blue becomes the green becomes the blue, and it just becomes a continual circle for all of that. These are two, again, really big components within an overall DevOps environment. And as you can see, there are only two small components here. There's a whole bunch of other things that we really have to talk about with respect to building an entire DevOps environment. All right, why should we consider that? Based on the slides that I've already presented and what we've done to this point, this looks like a lot of work. Why do we care about this? Why should we do this? Well, let me just give you kind of a dated example here, but this is just one really good example of how a DevOps environment could actually solve a particular problem. This was in the late 90s. I think it actually happened in 1997 or 98. I don't remember exactly the year. But basically, NASA designed, built, and launched the Mars Climate Orbiter. The idea behind the Climate Orbiter was that it was going to go to Mars, kind of orbit the planet, and evaluate the atmosphere. Basically look at the weather on Mars so that we could get a really good idea of what was happening on the planet from above, because we had the rover and everything that was down on the surface. And so this was a big deal for NASA, and they launched it. It launched successfully. It went on its way to Mars, had a lot of fanfare for that. And then when it came time to deploy the satellite to orbit the planet, effectively the satellite entered the atmosphere and burned up. It just died. And it was a very, very bad situation for NASA at the time. Nobody really knew what happened, other than the fact that they just lost almost $330 million worth of development efforts. So in the after action report for all of this, they really tried to figure out what went wrong. And what they determined was they had a third-party contractor that was working on a particular piece of software that was integrated to the project late in the game, and there was a bug in that particular software. And if you look at kind of what really happened, what the bug actually was, and I'll mention that here in a moment, but what I wanted to do is really point out that, you know, the NASA leadership effectively said, look, and this is a direct quote, "Our inability to recognize and correct this simple error has had major implications." Another way to say that is, yeah, we really screwed up here. Now, you know, this particular slide kind of it sugarcoats the problem a little bit, but if you haven't heard this story, the actual bug was the fact that the rest of the software measured everything in metric units, or standard units, as you know, the world calls it. The particular contractor that integrated the control software at the kind of very late in the game was all built on US measurements. So feet and inches, as opposed to, you know, meters and kilometers. And so what happened was the rest of the ship, the rest of the components thought that they were being measured in meters, and in reality they were being measured in feet. The difference caused the craft to actually stop in the atmosphere low enough to where the atmosphere was too thick and the craft just burned up. A really, really simple error that, had they understood the concept of, you know, test-driven development and continuous integration and continuous delivery, they would have caught that particular error early on in the process. But instead, they waited all the way until the application was deployed. and found the bug, and it was a big, big problem. So enough of that. That's just kind of the consequences of what happens. And I could have picked any number of highly public, failures, problems, situations to talk about here. But I found this one to be really interesting because it really was a very, very simple problem, for that. All right. Well, we talked about the why. Now, when we get into it, aside from the concepts that we've talked about, what really are continuous integration and continuous delivery? When we define these things, what are we really talking about from that? So a good definition that I like here is continuous integration is a mindset. It's a team strategy. Basically, it's a practice where members of your team integrate the work frequently and basically on a regular basis, not just once every quarter, once every week, once every few days. Generally speaking, multiple times a day, sometimes as soon as a simple thing is fixed from that perspective. And it gets integrated immediately, pushed into source control so that the build pipeline can pick it up and actually test it and get ready to work with it. Seems like a lot of work, but what ends up happening in this particular case is you find problems very early on in the process. If you have developers that are working on conflicting things for that, you very quickly find that when they integrate their work. And so continuous integration really is the concept of very quickly moving things from a developer's environment, the developer's workstation, into the source control environment that leads to the build pipelines and everything else. If you were to break it down, when we talk about the concept of the goals of continuous integration, we really have 5 basic goals. First and foremost, we want to make the best of collaboration. We want to really drive constant and good collaboration with everything. And because we're collaborating very well, we should be able to have a lot of parallel development going on. We don't have to do a waterfall approach to developing our code. We can develop in parallel because as it's possible, we're integrating things together. Because of that, we don't have to worry about our integration debt from the perspective of we don't have thousands and thousands of lines of code that we have to worry about integrating and consolidating. What we have is very minimal environments there. The smallest point of work, integration, move it forward, make sure it passed the test, get it into the pipeline for that, and effectively automate everything for this. There should be, from a continuous integration perspective, there should be nothing that has to be manually worked on, with the exception of the approvals as we go into the delivery phase, which we'll talk about here in a second. But the concept is automate as much as possible in everything there. So if we were to put a checklist in place as to how are we going to implement continuous integration, what we're really talking about here is getting the team all on the same page, making sure that we have all of the basic environment that we need, basically all of the process that we need, and the commitment and discipline of the team members and the stakeholders in the project all together. And if we were to look at this checklist and break it down into kind of 3 components here, from our version control perspective, we need to make sure that we completely understand our application and our test code, how it lives in the source control environment. We have to understand our configuration. What is it that we're doing to ensure that the source code is appropriately deployed as necessary and referenced and branched and versioned and labeled and all of those different things. From a data perspective, we have to make sure that we have a good database definition for every integration that we're working with. Hopefully it doesn't change so much, but if it does, make sure that we've got a really good definition of that associated with the code itself. From a testing perspective and from a deployment perspective, make sure that we have appropriate seed data, test data for everything that we're going to work with here, and make sure that we have the appropriate scripts in place to handle that. That's probably those few things right there are probably the hardest part of this whole process, or getting all of those things from a version control perspective into play here. Also have to have the right branching strategy, and you can look at these bullet points here underneath each of these things, but the concept is here, have the right version control system in place, the definitions, have a good branching strategy in place, and automate everything. Make sure that we have the ability to automate everything that we're working with. So that was continuous integration. Now let's talk a little bit about continuous delivery. So continuous delivery, at the end of the day, is a software engineering approach that teams produce software in very short cycle, making sure that you can constantly release the software at any given time. Somebody can say, we need to release, and we should be able to say, yep, we can do that for that. And then making sure, remember going back to that concept of a lean product or a minimum viable product, making sure that we always have that minimal viable product in place there. This concept allows us to very quickly deploy and deliver software and value to our customers from that perspective. So this is really kind of the concept that we want to get across. When we think about continuous delivery, we think about continuous deployment, this is what we need to be able to do. Always be able to deploy the software that we're building and working to ensure that we have the appropriate things in place in order to work with them. Again, why do we care about this? There are actually people that spend a lot of time studying these things. And there's a book out there called The Science of DevOps Accelerate. And within this book, they define basically 3 tiers of organizations: high performers, medium performers, and low performers. High performers have fully integrated a CI/CD and DevOps environment. Low performers still working with the old way of doing things. And these are just some statistics around looking at multiple companies that fall into these things. And it's a few years old now, it's back in 2017, but you can kind of see basically high performers deploy things multiple times per day, whereas low performers, weekly, monthly kind of deployments on things like that. But one of the major things to think about is this MTTR, the mean time to repair for this whenever a problem happens, when something blows up. High performers have the ability to identify the problem and fix it within an hour, whereas low performers, it can take up to a week for them to find a problem and actually fix it. And then we have to think about how we deploy all of those fixes for all of that. So that's just if you want some, really good nighttime reading, this book is a good book to have from that perspective. When you look at that from the perspective of the high performers and think about some examples here, here's another example written. It's basically the Phoenix Project has put together a concept or a compilation of software delivery performance, and they use some examples from some companies that we all know pretty well here. One of the things that's pretty amazing when you think about it, like Amazon has 23,000 deployments per day of the various things that they work on. I've actually tried to find that number for Microsoft just to see if I could compare it, and I'm not high enough on the chain in order to be able to receive that information, I guess. But the fact of the matter is, they deploy these things quite a bit. Facebook does deployments on a daily basis effectively. And Facebook is a really good example of that concept of blue-green deployment that I mentioned earlier. If you ever work with Facebook, if you're ever part of Facebook, my wife and I are both on Facebook, and it's really kind of funny because at sometimes my wife will come to me and say, "Hey, did you notice that Facebook did X?" And I'll say, "No, mine still looks the same." And then pretty soon, all of a sudden, I'll see that change that she was talking about. Because now I'm in, that the blue deployment environment. I've seen the change that's happened there. So these are just some concepts of how these organizations implement their continuous integration and continuous delivery. So with all of that said, how are we going to do this? And again, we're going to do this from an extremely high level. I'm going to go through it really quickly, but the concept here, how we actually do this from, our perspective here, is the whole concept of continuous integration is implemented by defining parallel builds, defining the appropriate branch policies, ensuring that our main branch or our trunk branch in our software version control is where we base all of our branching off of. We have multiple repositories that are all branched from the trunk, and we have a culture that enables us to collaborate and work and understands that we are continuously planning, continuously delivering, continuously ensuring value for our customers for everything, which of course means that we've got to put appropriate unit testing in place. We've got to do appropriate security scanning. We've got to do scanning for credentials, and everything comes down to how we gate the integration of what the developers are working on into the released product. And that's all accomplished through the idea of a pull request for that. Excuse me. So everything I've talked about up to this point has been very high level and kind of given you a very, abstract view of everything. And really what it does is this is kind of, if we boil it all down, these are the checklists that that we have to really go through. So for our common activities, these are the checklists there. And again, there's a link in the slide here to this particular article in real time that really drives into this a lot deeper. But I really like this particular checklist here. So if we think of the whole concept of continuous integration, it's meaningless without continuous delivery. And we've already talked about all of these things, so I'm going to go through this really quickly. But the whole concept of continuous delivery is making sure that we can fix something as soon as it breaks. We identify the break, we jump on it as quickly as we can, and we can identify where the problem is and solve it very quickly. That's really the goal that we're shooting towards. And our main branch, our trunk, is continuously ready to move into production. So whenever we have finally integrated everything, from a continuous integration perspective, we should be able to push the button and have the trunk deployed into production. We don't want to have a million different builds. We want to have one build for everything that's out there. And of course, we want to automate everything. Really the idea, continuous delivery. And again, if there's one thing on here that is the key point of all of this, it's that continuous delivery ensures that we're able to deliver value to our customers. And when we do have a problem, we're able to identify that problem and fix it immediately, which again increases that value from our customer perspective there. All right, so if I were to summarize everything that I just talked about in terms of DevOps, we really are talking about people, process, and products that come together to enable continuous delivery of value to our end users. I think if anything you get out of this particular presentation, get that definition down. That's what we're talking about, delivering value to everybody. So in a nutshell, that is DevOps, very high level for everything that we talk about. So now let's get into the actual meat of what we're going to talk about here. Really applying all of the concepts that I just mentioned to the idea behind data operations. How are we going to implement data operations within the environment? So with all of that in mind, let's define DataOps. So data operations, or DataOps, is effectively a discipline that's starting to come to light that really takes all of the concepts of that our DevOps teams have learned and applied it to the work that the data engineer and the data scientists are doing to effectively bring data value to their particular customers. It doesn't always mean that it's a product that we're delivering in terms of something that gets shrink wrapped and sold on the shelves, but it's a product from the perspective of my business customer absolutely needs this. And if we apply the same concepts that we just talked about to the data operations, what we find is that concept of continuous value can really lead to very good things, from the perspective of my end users. Microsoft's tooling for DataOps is really rooted in the concept of a tool that we call Azure Data Factory. So Azure Data Factory is effectively a code-free ETL as a service tool. The concept behind Azure Data Factory is that it gives us the ability to create data pipelines, to orchestrate data pipelines that move data through whatever system it is that we have to think about, and transform that data, make it available for the end users that are going to work with this. So Data Factory is kind of Microsoft's modern ETL, ELT tooling. It's designed effectively to be not just a replacement for SSIS, although SQL Server Integration Services definitely still has a place in the world. In the modern digital transformed world, Data Factory is really meant to be that thing that organizations use to move their data and get it available and ready for the consumers to actually consume for that. Now, I'm talking about Data Factory as a standalone product here, but understand that Data Factory is part of our overall Azure Synapse Analytics platform. Everything that I'm talking about here today related to Data Factory applies to Synapse Analytics as well. So there's nothing different that you have to think about or do. It's the same code, it's the same backend, it's the same stuff that we're talking about between everything there. Well, if we think about the two really big components that I was really highlighting earlier, continuous integration, continuous deployment, CI/CD, how does it apply to Data Factory? So if you look at this particular picture here, we really have three main pillars from a technology perspective here. The first is our source control. And again, as we talked about, Git is our source control pillar for everything. But we talk about the source control pillar we talk about the release management pillar, and then we talk about the deployment environment for that. Now, how we work in this environment, we make an assumption that we have three main environments that we're going to work with in our data environment. We're going to have our dev environment, we're going to have our test environment, we're going to have our prod environment. Some customers have more than three environments. I worked with one very large customer that also has an environment that's very specific for their hot fixes, for example, things that, service packs, things like that for that. But generally speaking, we're going to focus on three environments, dev, test, and prod. And what this allows us to do is really separate our roles and responsibilities for this. One very key component here is that when we think about our source control environment, we think about our Git environment that the developers are actually working on and continuously integrating to. That is the only Azure Data Factory that is integrated with our source control. Our test environment and our production environment are not integrated with the source control. They get their deployments through our release management system or through our pipeline, our data pipeline, as part of a DevOps deployment there. So that's a really key component here, because what'll happen is a lot of people will think that, well, we're going to have three environments, dev, test, prod, and we're going to integrate each of those with our source control environment, and we're just going to integrate them with a different collaboration branch. And that's just not the way to do it. You have your dev environment is the only one that's integrated with your source control, and your test and your prod, or in the case of my one customer, the hotfix, is integrated as part of the DevOps pipeline that we're working with here. The life cycle looks like this. If we think about the development environment, that's basically what is controlled by our source control, our Git environment. It's the heart of everything. When we think about, the overall collaboration branch, we have multiple feature branches. So developers would be working on a feature branch, and they would integrate that feature branch into the collaboration branch. And then the collaboration branch ends up being published as part of the Data Factory environment. Now, this is something that needs to be defined, and something that can be really confusing for some people. And that is the concept of that publish button inside of Data Factory. And I'll talk about it more here in a minute. But what that actually does, whenever you click publish inside of Data Factory, is it takes the collaboration branch that you're working on and generates all of the deployment artifacts necessary to allow the cloud-based Azure Data Factory execution system to execute that pipeline. So it takes all of your different data sets, all of the pipelines, all of the data flows, all of the things, the assets that are part of your data factory, and generates an ARM template, and then that ARM template gets deployed to the Data Factory production environment that then executes your pipeline for that. If you think about that for a second, what you can really start to understand why you wouldn't want to have your test environment or your production environment integrated with your source control environment. You want to enable those things once it's been published to the dev environment and it's been validated from the unit test perspective. Then it gets handed off to the release pipeline, which then deploys it into the user acceptance testing, or the test environment. And then from there, once that's validated, it gets deployed into production. So your production environment does it. Your developer never publishes to production. Remember what I said earlier about your trunk or your main branch as being your production environment. Your developer in this case is never ever touching your production branch, your main trunk, if you will. The Git environment works with the collaboration branches. The collaboration branches publish. The dev environment does the unit test. Then it moves through the pipeline to the test environment, passes all of those tests, and then gets pushed into production. That is the life cycle that we implement from a CI/CD perspective with Data Factory. Now, you have two options whenever you create Data Factory. You don't have to integrate it with Git, but if you do integrate it with Git, obviously you get the benefits of all the CI/CD stuff that I talked about. But what's really nice about Git integration and Data Factory, even if you don't think about CI/CD and DevOps and everything else as a concept, is it gives you the ability to have a snapshot of your environment. It gives you the ability to save your incomplete work. You don't have to always publish. If you ever worked with Data Factory without Git integration, you know that you can't actually publish incomplete pipelines. If you want to do something and you need to do some further refinement or whatever, and your pipeline has an asset like a data set that's not complete, maybe it didn't pass a credential test or something like that. Without Git integration, you actually can't save your work. You can't publish that to the Data Factory environment. So Git integration allows us to do that, among other things, for that. Now, how do we actually go about creating these branches from within Data Factory? So if you're in Data Factory, you go into the user interface, and on the left-hand side, here in this little graphic that I've got on the slide here, you'll see your Git integration. If you pull that down, if you click on the little down arrow there, the drop down, what you can see is that you have the ability to create a new branch for that. And that's where you would start your collaboration environment here. So starting from scratch, you have one branch, your master branch, and then you have a branch that ADF creates for you called the ADF publish branch. And that is effectively the two branches that you will always have in your Git environment. Now we've recently made some changes in Data Factory that allows you to rename your publish branch to whatever you want to for that. But you can go into the UI, you can create the new branch, and then you can, on the back end in DevOps, set up your pipeline requirements that basically gate all of the check-ins and all of the things that you do. So as a developer, whenever you have finished work in your feature branch and you're ready to integrate, and you create that pull request into the collaboration branch, then what happens is DevOps will implement the policies that, in this particular case, what we're saying is that we check for merge conflicts, number one, and number two, we ensure that we have required reviewers who have reviewed the pull request and ensured that it fits the model that we're trying to work with here. And that's the concept of the pull request and creating the automated reviewers and everything else. Remember, the concept of the CI/CD process is that we continuously automate everything as much as possible. And then once we're done with that, and I've already kind of talked about this, but whenever we click publish, what happens now is that we publish that collaboration branch directly into the Data Factory execution environment, creates an ARM template, collects all of our assets, and moves it into the Data Factory application environment The key point is that when you click publish, you're not just publishing your stuff. You're publishing every change that has been collected into that collaboration branch. So it's really important to understand that whenever you're going through this. I mentioned this earlier as well when we talk about the fact that when you create your initial Git integration with Data Factory, you now have the ability to rename the publish branch, which by default is called ADF_publish, but you can change the name however you want it. And again, remember what publishing does is it takes all of our assets and deploys them to the Data Factory execution environment for everything there. Now, outside of Data Factory, what we need to do is in DevOps, we need to set up our release pipelines for that. And what the release pipeline will do is it will take that information that's been deployed to the ADF publish environment after it passes all of the unit tests, the smoke tests, everything that you've got set up from a testing perspective, and then takes that deployment and pushes it into the other data factories. So our test data factory and then our prod data factory. And the idea here is that we'll create a trigger that every time we see a publish to the publish branch, we will then trigger the release pipeline that takes the output of that test from the development environment and pushes it through the pipeline and all of that. It's a lot easier said than done. I understand that. But the concept here is that we create the pipeline, we trigger it based on the publish, and then we will set up the pipeline to effectively say, here's the artifact, which is all of the things collected as part of the publish environment, and here are the various stages. Part of it moves to UAT, part of it moves to prod once everything in test is approved, and we work with that. All right, so kind of to close things down, since I know I'm getting close on time here, what we want to really highlight through all of this is that from an integration perspective, kind of the key thing that we talked about earlier was that only the dev environment is integrated with our source control, and we want to make sure that all of the secrets and all of the credentials and everything else, rather than being part of our development environment, actually get stored as secrets as part of our Azure Key Vault. There's a whole bunch of documentation here related to that and how that all kind of ties together. But your team members should have read permissions on the factory, and the only people that have the ability to publish that factory are the people that have been designated kind of the leaders from that environment. And there's a link here for that particular concept and that pattern that really says how we can set up all of those roles and responsibilities for all of that. All right, so I'm pretty much out of time here. As you can see, there's so many things that we can talk about in this particular environment, but I hope what we were able to do as part of this presentation was give you an idea when we talk about DevOps, what it means, and then very specifically how we can apply that into our data environment and create DataOps from all of that. I've put a lot of different links in here in the slides, so download the slides, go to the resources there. And as I said earlier, if you have any questions or anything, please feel free to reach out to me through any of the channels. I'm pretty active on Twitter, pretty active on LinkedIn from that perspective. If you do follow me on Twitter, you'll find that I spend a lot of time talking about my dog. So if you don't like dogs, I apologize. But nevertheless, there we are. So with that, Dion, I'll turn it back to you.
All right, well, we don't have any questions at this moment. Thank you so much, Ted. Why don't we go ahead and give it about 30 more seconds, and we can see if anyone hops on with any questions.
This is one of those topics that people look at it and it'll probably take about 3 days for them to realize what questions they actually have, because there is a lot of information presented in this hour.
And we've gotten this question a few times, so I'll go ahead and answer it right now. Yes, the slides and the video will both be published on the Reactor YouTube page, and I will share that link in the chat one more time. I've also shared a link to the Reactor survey. If you have a few minutes and you can fill that out, that'd be greatly appreciated. The first question I'll ask you is what the event code is, and the event code for this one is 12303. And then, Ted, there is a question for you. It said, should you have a dedicated DataOps role in your team?
That is a fantastic question, and the answer is yes, absolutely. And that DataOps role could be an individual, or depending on the size of your organization, could be a team. But that role is the one that would have the permissions to actually publish from the collaboration branch into the ADF publish branch. Even if it's a temporary role, or I shouldn't say temporary, but even if it's a not full-time role, you share that responsibility. Someone or some group needs to be empowered with that particular capability.
Awesome. And then another question is, what's the most efficient way to correct conflicts when publishing an ADF?
Oh, wow. Honestly, so again, another great question, but honestly, the best way to manage conflict is this whole concept of continuous collaboration. The longer you work in a vacuum and then try to come together and integrate everything, the more conflict that you're going to have. So a good example of this, one of the customers that I work with, what they will actually do is they will bring representatives from multiple teams and have them work, quote unquote, in the pit together. They all kind of work together. And so they're constantly, even though they report to different people, they have different responsibilities, they're all working together in a very close proximity. Therefore, they have the ability to continuously collaborate and resolve some of those conflicts early. But unfortunately, there's no easy button there. You have to rely on the people to be able to do that.
Perfect. And we have a couple more if you have a few more minutes.
Yeah, sure.
Perfect. What environment are the devs using to edit their own branches?
All right. For the most part, now this isn't a de facto rule, but for the most part, developers that are developing data pipelines are using Azure Data Factory, the user interface directly within that. Now, at the end of the day, all of these Data Factory components are just JSON files. So there are developers who are really comfortable with JSON and know what they need to accomplish. So they'll use a tool like Visual Studio Code to work with the artifacts that would be part of your Data Factory UI. but generally speaking, the developers will use the Azure Data Factory UI. Or in the case of Synapse Analytics, they will use the Synapse Studio, which effectively is just a housing for the Data Factory UI.
All right. And then I think this question is asking, can the DevOps pipeline be integrated with data migration?
Yes, so that's a excellent question that comes up all the time as well when we're thinking about data migration. And one of my customers coined a term that I absolutely love in this particular process. And one of these days, I'm going to spend a really good amount of time defining all of this. But the concept in data migration and moving data from your on-prem sources into cloud sources, the concept of undifferentiated heavy lifting. And the idea there being, trying to figure out why do we always have to build a new data set, a new schema, a new capability for all of these things. And so, yes, the idea would be let's generalize those things as much as possible and make data migration part of your data pipeline for that. Now, again, that I just said a lot, but the idea here is that there are many tools that kind of help us with that. Change data capture being one of them. There's a number of things for that, but yeah, great question.
Awesome. And then just one more. Is there any existing modules or learning paths on Microsoft Learn tutorial that you would recommend for learning more about Data Factory?
So yes, if you actually open up in Azure the portal and go to the Data Factory user interface, the home page for the Data Factory has a series of tutorials and videos that are linked in various locations. Some things are on the official Data Factory blog, some things are part of the Microsoft Learn environment, and some things are various YouTube videos that have been created by various people in the product team. But the one place that consolidates all of that is the Data Factory user interface in the Azure portal that brings that all up.
Perfect. And I will share a link to Microsoft Learn in the chat. So if anybody wants to check that out, we'll have that ready for you. Let me just grab that really fast. All right, and then Ted, someone is asking if you could share your LinkedIn and Twitter here. Are those things you have pulled up right now?
Yeah, they're Ted Malone is my my Twitter, and I will take a second here to grab my LinkedIn really quick. Make sure that I get it right. I have shared this before where I've missed part of it. And here we go. And there's my LinkedIn.
Wonderful. And it looks like that's it for questions as well. So thank you all again for joining us. The recording and the slides will be on the Reactor YouTube page in about 24 to 48 hours. And if you do have a moment and you could fill out our Reactor survey, that would be great. I've also shared a link to our Reactor meetup pages and our newsletter where you can get updated on all our upcoming events. And thank you so much again, Ted, and have a great evening, everyone.
Thank you very much.